Good day, everyone. Good day, sir. I'm Jimwell A. Deramas from BIT3A Set A, and I'm here to discuss ABS anti-braking system and TCS traction control system. First of all, what is anti-braking system or ABS? It prevents wheels from locking up and cars from skidding when the brake is harshly applied, especially on slippery road conditions, guaranteeing safer driving. Ang purpose po ng ABS or anti-braking system is siya po yung nagpapanatili na makontrol po natin yung ating ating control sa mga kotse or motor po natin, especially sa mga slippery road or mga madudulas pong daan. Example na lang po natin is kapag nag-brake po tayo sa madulas na area, ang tendency po nun is mag-i-skid po or dudulas po tayo. Mawawala po tayo sa control sa ating mga sasakyan. Pero kung meron po tayong ABS, makokontrol pa po natin ito kasi hindi po siya totally mag-brake at magkakaroon po tayo ng control sa ating mga sasakyan kahit nasa slippery road po tayo. Principles of anti-lock braking system. The purpose of anti-lock braking system is to provide safety to drivers by reducing the chances of wheel lock and preventing cars from skidding during heavy braking. When the brake is applied harshly on vehicle, its wheels get locked up. Once locking up occurs, cars are no longer able to move, causing drivers to lose steering control over their vehicles. An ABS serves to keep drivers from dangerous situations arising in the wake of losing control. So, as we mentioned kanina po, yung ABS po is siya po yung nagpapanatili ng control po natin sa mga wheels natin, lalo sa mga madudulas na area. Siya po yung nagpe-prevent na mag-lock po yung wheels po natin na mag-a-avoid po siya ng skidding or pagkadulas sa mga madudulas po na area. Components of anti-lock braking system. First is speed sensor, mounted at every wheel of a car so that each one can detect when the brake is being heavily applied and control subsequent locking up. Next is pump. Pump plays the role of restoring the pressure that has been released from the brake. The third one is bulb, located in the brake line and operates in three positions. In position 1, where the bulb is open, pressure coming from the master cylinder flow past the brake. In position 2, where the bulb blocks the brake from the master cylinder, the pressure is maintained during hard braking. In position 3, the bulb releases the pressure held in the brake. Next is controller. Controller receives the information from the speed sensor and has control over the bulb. Operation of anti-lock braking system. The controller monitors the speed sensors at all times. It is looking for decelerations in the wheel that are out of the ordinary. Right before a wheel locks up, it will experience a rapid deceleration. If left unchecked, the wheel would stop much more quickly than any car could. It may take a car 5 seconds to stop from 60, 60 miles per hour or 96 kilometers per hour under ideal conditions. But a wheel that locks up could stop spinning in less than a second. The control, the ABS controller knows that such a rapid deceleration is impossible, so it reduces the pressure to the brake until it sees an acceleration. Then it increases the pressure until it sees the deceleration again. It can do this very quickly before the tire can actually significantly change speed. The result is that the tire slows down at the same rate as the car, with the brakes keeping the tires very near the point at which they will start to lock up. This gives the system maximum braking power. When the ABS system is in operation, you will feel a pulsing in the brake pedal. This comes from the rapid opening and closing of the bulbs. Some ABS system can cycle up to 15 times per second. Our next topic is traction control system or TCS. Traction control helps limit tire slip and acceleration on slippery surface. In the past, drivers had to pedal the gas pedal to prevent the drive wheels from spinning wildly on slippery pavement. Many of today's vehicles employ electronic controls to limit power delivery for the driver, eliminating wheel slip and helping the driver accelerate under control. Ang purpose naman po ng TCS or traction control system is siya po yung nagko-control ng gulong po natin, especially sa mga madudulas pong daan na siya po yung nagko-control sa mga gulong po natin na mag-prevent po siya na mag-slip or madulas po sa mga madudulas pong daan. Example lang po natin 'yan sa kotse po natin pagka sobrang dulas po ng daan natin, mag-a-accelerate po ng sobra yung gulong po natin sa sobrang bilis ay sa sobrang sobrang dulas po, and then yung traction control po siya po yung maglilimit ng gulong po natin na umikot para ma-accelerate pa rin natin yung mga vehicle natin ng kontrolado. Principle of traction control system. In modern vehicles, traction control system utilize the same wheel speed sensors employed by the anti-lock braking system. These sensors are measure difference in rotational speed to determine if the wheels that are receiving power have lost traction. When the traction control system determines that one wheel is spinning more quickly than the others, it automatically pumps the brake to that wheel to reduce its speed and lessen wheel slip. So, isa rin pong purpose nito is, yun nga po, sa mga madudulas po nating daan, kapag na-sense po ng traction control system na iisang gulong po natin is nag-accelerate ng mas mabilis kaysa sa ibang gulong natin, doon po siya magko-control or doon na po siya gagana. Para magkaroon po ng balance sa ikot po ng gulong natin sa ibang gulong. Components of traction control system. Wheel speed sensors to monitor the speed of rotation of front wheels or all four wheels. Hydraulic modulator to control braking, pump and high pressure. Accumulator to generate and store pressure to apply brakes. Next is control module to interpret the information from wheel speed sensors and direct to the hydraulic modulator to apply brakes whenever necessary. Next is operation of traction control system. The purpose of traction control is to detect when tire loses grip, causing the wheel to spin, and then work to stop or slow down the rate of spin. If the ABS sensors detect that the wheel is spinning, the vehicle's onboard computer will momentarily cut the engine's output to allow the wheel to slow and ideally regain traction. Para mas makomprehend po natin ang topic natin ngayon tungkol sa ABS at sa TCS, naglagay po ako ng video para mas magkaroon po tayo ng idea kung paano po ang operation nilang dalawa.
During emergency braking or on slippery surfaces, a driver may apply braking force that is greater than the tire's capacity for grip. If this happens, the wheels can lock up, causing the vehicle to skid out of control. By preventing this lockup, the vehicle stops sooner and remains under the driver's control. The anti-lock braking system, or ABS, provides this assistance. So, how does it work? Sensors on each wheel constantly measure their rotational speed. The ABS control module samples this data continually, comparing the rotational speed of each wheel. If one or more wheels is rotating slower than the others, a condition that will bring the wheel to lock, the system takes action. It instructs the brake master cylinder to direct brake force away from the locking wheel, so it releases and regains traction. As the wheel begins to turn again, braking force is momentarily reapplied. This process is repeated up to 20 times a second and causes the characteristic pulsing feel through the brake pedal. As a result, the driver's intended brake force is applied without locking up and skidding, allowing the driver to maintain steering control while braking, meaning that stopping distances may also be reduced. The vehicle on the left has ABS. The vehicle on the right does not. Both vehicles are travelling at 100 kilometers per hour. Let's simulate an emergency braking situation and see what happens. Both drivers apply their brakes at the same time and with the same force. But the vehicle with ABS maintains control while braking and is able to steer around the obstacle. ABS helps the driver avoid accidents by preventing lockup and loss of traction. This allows the driver to maintain steering control during heavy braking and may help to reduce stopping distance. During heavy acceleration from a standstill or when merging with traffic, wheels can lose traction, reducing the driver's control of the vehicle. Traction control prevents this wheel slip. So, how does it work? The traction control module monitors data from the wheel speed sensors and the powertrain control module. It samples this data continually, comparing the rotational speed of each wheel. If one or more wheels is rotating faster than the others, indicating traction loss, the system takes action. It instructs the powertrain control module to reduce torque and the braking system to apply braking pressure to the slipping wheel until it regains traction. Traction control allows drivers to safely apply heavy acceleration when merging with fast-moving traffic and on slippery or loose surfaces.
So that's it. Thank you guys, and thank you sir for listening and watching to my video. I hope you learned something today. Thank you for listening.